Hello, everyone. Um, my topic for today is bending a spoon with your mind using neurotechnology. In that regard, we'll be exploring neurotech and software innovation. So, bending a spoon with your mind is a classic magic trick that you probably either heard or seen about. It usually contains some form of showmanship coupled with a rigged spoon. But the question today is, how can we go about making it technically real with neurotechnology? Well, before we get into that, let's first define what exactly is neurotechnology. Neurotechnology is a multidisciplinary field integrating neuroscience, engineering, and computer science. It involves the development and application of technologies designed to understand, interact with, and even manipulate the nervous system. There are two main facets when considering neurotech. The first is the application of neurotech in recording and measuring brainwaves. Neurotech allows us to understand and decipher the complex workings of the brain. There exist both invasive and non-invasive methods, both with their own advantages and disadvantages. Invasive procedures enter the body through incisions or instruments, while non-invasive procedures do not break the skin. One of the most widely known tools for recording brainwaves is the electrocephalogram, or the EEG. These are probably what we're all used to seeing, a bunch of wires and nodes strapped to your head looking all cool and fancy. And to be fair, they are. These devices record the tiny electrical impulses by the firing of neurons in the brain. These are electrical signals on the magnitude of microvolts. To put that into perspective, the human body, as the conductor it is, naturally picks up electrical noise from the environment, mostly from power lines, which is then on the magnitude of millivolts. This is already an electrical noise level of about 100 to 1,000 times. EEGs are able to filter through these while providing a meaningful representation of a person's brainwaves. Other technologies exist as well, such as the fMRI method, which produces different but similarly useful data. The other facet of neurotech involves actively interacting and manipulating brainwaves. These are usually used in highly specialized systems and in the medical field. Two well-known methods is the transcranial electrical stimulation and the deep brain stimulation, with the former being a non-invasive method and the latter being invasive. Neurotech allows us to not only figure out what is going on in the brain, but actually try to attempt to alter it. Now, neurotech has a well-established role in the medical field, where most of the groundbreaking research and practical applications have mainly been developed. Deep brain stimulation, as mentioned earlier, is able to be used in the treatment of Parkinson's and OCD by sending electrical impulses to targeted brain regions. The advanced brain-controlled prosthetics allow amputees to control artificial limbs through their thoughts. Advancements in medical neurotech underscore how precise and effective existing methods have become. This also sets the stage for broader applications beyond the clinical environment. Now you might be wondering, why should we, as software engineers, care about neurotech? The answer is simple. Neurotech introduces a completely new way of interacting with computers, one that goes beyond the traditional inputs such as keyboards, mice, and touchscreens. Imagine being able to control your computer or a software application directly with your mind. With brain-computer interfaces, this isn't science fiction anymore. It's already being explored in various forms today. Neurotech has the potential to enhance accessibility for users with disabilities, enable more immersive gaming and virtual reality experiences, and even create user interfaces that respond in real time to our mental states. OpenBCI is one such company making use of brain-computer interfaces. In their demonstration in 2023, they showed the capabilities of their BCI system. Christian Balin, who suffers from severe muscular dystrophy, was able to fly a drone using a VI headset equipped with OpenBCI's technology. The technology used an EEG that detected the brainwaves and used a BCI to interact with the drone. Neuralink, which many of probably have heard about, is attempting to create an invasive BCI by implanting their chips directly into a person's head. This would create a seamless brain-computer interface and allow for more reliable brainwave data to be captured and used. But Ron, what does any of this have to do with bending a spoon? I'd like to show you a video that sparked this topic for me in the first place. Voila, bending a spoon with your mind. Well, technically it's a fork, but you get the point. Um, if it wasn't clear what was happening, there's an EEG that, when the man focuses intently, causes a servo motor to be activated, pulling the spoon back. Okay, cool, now what? Well, one of the key takeaways I had from that video, though, was that there's now commercially available EEGs that one can simply purchase and do stuff with. Those fancy things you expected to see only in hospitals or YouTube videos is now easily accessible to a consumer. This project demonstrates that even with off-the-shelf EEGs, we can create interactive, mind-controlled applications. But is bending a spoon really the best that one can do with this technology? Well, perhaps consider playing a video game with your mind. Perry Carial is a Twitch streamer who is known for using B-side technology to play video games. This is definitely a big step up from using an EEG to bend a spoon, but the concept stays the same. She uses an EEG to measure her brainwaves, which is then used to determine inputs into a game. And to be clear, I'm not talking about games like Tetris or Minesweeper. I'd like to show you a video of her. This is a video of her playing Elden Ring, which, for those unfamiliar, is a game known for being quite hard to play regularly, which makes this all the more impressive. So how did she do this? Well, as she has explained, she used an emotive Epoch X EEG that she purchased, along with the provided API and software to measure her brainwaves. The image here shows a brain activity visualizer that was included in the software. Four distinct thoughts were chosen based on the brainwave patterns they then produced. Using a machine learning algorithm, she trained her system to determine when those four distinct brainwaves were detected. By mapping the brainwave patterns to different keys, she was able to perform different actions in the game. Of course, a game requires more than 4 keys to play, so for movement and aiming, she used an eye tracker and head tilt measuring system. However, sprinting, dodging, attacking, and healing were controlled purely by her brain. What is interesting to note, though, is that it's not yet as simple as imagining just sprinting or dodging. As she has explained, there had to be quite distinct thoughts, even involving brain activity linked to different senses. So, for sprinting, she imagines herself pushing a cube. For dodging, she imagines herself spinning a plate to "You Spin Me Around" by Dead or Alive. For attacking, she imagines a little cricket hopping and also pulses her inner ear muscles. And finally, for healing, she imagines getting super tense, hot, and angry. These 4 thoughts involve different parts of the brain and create 4 distinct brainwave patterns, enabling different actions to be done. There exist many cool projects that make use of neurotech, and it's becoming increasingly easier to develop these, whether it be playing a video game, creating music using the brain, or enabling interactive immersive VR experiences. It is evident that these technologies are not out of our reach anymore, and just might be worth giving a shot yourself. Thank you. Any questions?